Jensen Huang didn't just build faster silicon, he built a trap.
Today, if you want to train a serious AI model, you don't really have a choice of hardware. You have a choice of how much Nvidia you can afford.
Here's how a graphics card company became the mandatory backbone of global intelligence, and why rivals with billions of dollars still can't break out. A GPU isn't one brilliant worker doing tasks fast. It's an army of thousands of simple workers doing tiny calculations all at once. Great for rendering pixels in a game. In 2006, Nvidia noticed researchers hacking graphics cards to do scientific math. So they released CUDA, a programming toolkit that let developers run code on Nvidia GPUs. It was proprietary. It only worked on Nvidia hardware. And Nvidia put it on every chip they shipped, even cheap ones, for free. Wall Street called it a distraction. Millions spent on software for scientists who barely bought chips. But university labs got free parallel computing power, and grad students started learning CUDA as part of their coursework, not because anyone said it was the future, but because it was the only good toolkit that was free and everywhere. Nvidia wasn't selling chips to scientists. It was teaching an entire generation of programmers its language, years before the prize even existed. In 2012, a neural network called AlexNet shattered an image recognition competition, trained on Nvidia GPUs using CUDA. Suddenly, the deep learning revolution was built on a stack every AI researcher already knew. Competitors looked at Nvidia's chips and thought, we can match those specs. Many have. AMD's hardware is genuinely competitive on paper. But hardware was never the moat. Picture an AI engineer offered an AMD chip that's just as fast for less money. Easy switch? Except every library, optimization tool, tutorial, and open source model their team relies on was written and tuned for CUDA for 15 years. Switching isn't changing a tire. It's asking an English-only company to instantly run on a language almost nobody on the team speaks, with half the manuals untranslated. That's a switching cost, and Nvidia engineered it to be unbearable. Every year, a rival closes the hardware gap, Nvidia widens the software gap. And CUDA runs on everything, from a $200 laptop to a $1 billion supercomputer. The same skills scale from a dorm room to a national lab. That universality is the moat. Jensen Huang's real masterstroke wasn't predicting AI would need GPUs. It was spending years, while almost nobody was watching, making sure that when the moment came, the only language the industry knew how to speak belonged to him. You don't beat a moat like that with a faster boat. You beat it by teaching the world a new language and hoping they're willing to learn it. Is that moat actually unbreachable? Let me know in the comments, and subscribe for the next one, where we look at who's actually trying to cross it.